Hi students, this is Sivakumar, 11th Standard Mathematics, Chapter number 1, Exercise 1.3. Before getting to that exercise 1.3, you must be knowing about that. The definition of function, different types of functions. Function. Here is a definition. Let A and B be two sets. The relation f from A to B is a subset of A cross B. Instead of that or, you are given f. The relation is f over here is called a function from A to B if it satisfies the following two conditions. For all A, small a belongs to capital A. Here, small a is an element of the set capital A. There is an element small b belongs to capital B such that A comma B belongs to the relation f. Second condition, if A comma B belongs to f and even A comma C belongs to f, definitely B and C must be equal. What it means? It means an uniqueness. What do you mean by uniqueness? Each and every element of the domain has an unique image in the codomain. That is given clearly. A function is a relation at which each element in the domain is mapped to exactly one element in the range. Here, the set A is called the domain and set B is called the codomain. If A comma B is in F, then we write f of A that is equal to B. F of A that is equal to B, that is the image of A is B. See, the element B is called the image of A and the element A is called the pre-image of B. And f of A is known as the value of f at A. Okay. The set of all B such that A comma belongs to f for some A belongs to the set A is called the range of the function. If B is a subset of or refers real numbers, set of all real numbers, then we say that the function is a real valued function. I'll give an example later on, you can understand. Two functions A and B, two functions f and g are said to be equal functions if their domain are same, and f of A that is equal to g of A for all A in the domain. Okay. Now, some elementary functions this and all have learnt in that 10th standard itself. Now, subdivision number 1. Let x be a non-empty set. The function f from x to x defined by f of x equal to x for all x belongs to capital X is called the identity function. Look at that diagram. This one is a domain, this one is a codomain. Look at that, x and x, domain and codomain are equal. The image of A is A itself. So the A is associated with the same A. So B, the image of B is B itself and image of C is C itself. So each and every element of the domain is associated with itself. It is an example of identity function. Now look at that second one. It's an example of a constant function. Each and every element of the domain is associated with only one element in the codomain. All the elements of the domain associated with only one element in the codomain. It is called a constant function. That is given clearly here. Let x and y be two sets. Let C be a fixed element of y. The function f from x to y defined by f of x equal to c. For all x belongs to capital X is called the constant function. Now different types of functions. First definition, look at that. A function f from a to b is said to be one-to-one if x comma y belong to that set A. If x is not equal to y, implies f of x is not equal to f of y. For equivalently, f of x equals f of y implies x equals y. A function f from a to b is said to be onto if for each b belongs to capital B, there exists at least one element a belongs to a such that f of a that is equal to b, that is a range of f is b. Here's an example. Listen here. In the set X, capital X, this is called the domain, this one is called the codomain. According to the definition, look at that. The image of A is X, only one image. Image of B is Y, only one image for B. Image of C is Y. That is also C has only one image, B has only one image, A has only one image. So it is an example for one-to-one function. Right here, A has only one image X, B has only one image Y. But look at that Z has no pre-image in X. Here X has the pre-image A, Y has the pre-image B, and same Y has a pre-image C, but Z has no pre-image. So it is an example of not onto function also. One-to-one at the same time not onto. For onto means each and every element of the codomain must have the pre-image image in the domain, but Z has no pre-image in the domain. Therefore, it is not onto. It is also not onto because Z in codomain has no pre-image in the domain X. Now look at the next one. It is an example of one-to-one as well as onto. Here X is the domain and Y is the codomain. Image of A is X, only one image. Image of B is Y, only one image. Image of C is Y, only one image. For each and every element of the domain has only one image in the codomain. So it is one-to-one function. At the same time, each and every element of the codomain has a pre-image in the domain. So nothing is left out in codomain. Therefore, it is a one-to-one as well as onto function. If the function, what I explained, everything is given here. Here, read out. Then another name for one-to-one function is injective function. This and all not new to you. This one have learnt in 10th standard itself. So one-to-one function is called injective function. Onto function is called surjective function. Both one-to-one and onto, that function is called bijective function. So once again, one-to-one alone, injective. Onto alone, surjective. Both one-to-one and onto, we can call it as bijective function. For proving a function is one-to-one, it is enough to prove any one of the following. If By considering x is not equal to y, if we prove f of x is not equal to f of y. Or equivalently, if we consider f of x is equal to f of y, it is enough to prove x and y are equal. Then we can say the function f from a to b is an one-to-one function. Remember, it's a very important note. Now, inverse of a function definition. Here, look at that diagram. A function f from x to y. Here, the domain has 3 elements, even the codomain has 3 elements. The image of A is z, image of B is x, image of C is y. Now, the reverse, pre-image of x is B, pre-image of z is A, and pre-image of y is C. Here is a definition. Let a function f from capital X to capital Y, capital X and capital Y are sets, capital X is the domain, capital Y is the codomain, be a bijection. You know the meaning of bijection? A function which is both one-to-one and onto, call it as bijective. The function g from y to x, reverse this f from x to y. Here g from y to x defined by g of y that is equal to x. If f of x that is equal to y is called the inverse of f and is denoted by f inverse. Okay. See, the image of A is x. That means f of x that is equal to y. F of x that is equal to y, like that. Here x, small x represents A, small y represents z. Now f inverse that is equal to g, that is from y to x. So f of z, g of z that is equal to g of z that is equal to a, that is g of y that is equal to x. Here y represents z and x represents a. Okay. So this is the definition of inverse function. Before we move on to that exercise 1.3, so revise all the definitions. Then I start that exercise 1.3 in the next video. Thank you, children.